Hello, it's Duncan. This video is another that I recorded with Dmitry Kandilov, covering material from Java to Kotlin, a refactoring guidebook. This is chapter 9, multi to single expression functions. If you like it, you should buy the book, and definitely subscribe to Dmitry's YouTube channel for more of that hat. Oh, I think we're there. Hey, Dmitry.
Hello. Hi, Duncan.
Oh yeah, that's me. Good intro. So we're back again. We did Life. Was that last week? Feels like last week. And this week I've been working a bit on the book that Nat Price and I are writing, Java to Kotlin, a refactoring guidebook. And I've just written a chapter on refactoring to single expression functions because I love single expression functions. And I thought it would be interesting to go through some of that material here, some of that refactoring, because we love refactoring. Is there anything you like more than refactoring?
Maybe bounty hunt? I don't know.
So you've got a project, I think. Do you want to share your screen? Let's have a look.
Yeah. Can you see my screen now?
No. Well, that's a great start, isn't it?
Absolutely.
We may need
What
to
about now?
I've got a thing. Add to stream. There we go. Okay, so this example came about because we've got this example application called Travelator, which organizes trips around the world. And one of the classes inside it is email address, and it's this is the class after we have after we've converted to Kotlin. So it was Java, and now it's Kotlin. And as a result, it has this parse method that used to be a static method in Java.
Just for the record, I haven't read the book. I don't know what's going on here. I'm just a typist. So parse method.
So it's got this parse method, which is called from Java somewhere. I think there's some tests. If we look, email address tests.
Okay.
And so you can see that these are still Java, and this shows that you can access that method as email address parse, and then there are lots of different ways that it fails, depending on whether it can find an @ sign, really. And an email address is just 2 bits. It's the bit before the @ sign, it's the bit after the @ sign. So we sort of pre-parse it to check it's all good. Yeah. And the problem that we're trying to address here really is that that's an awful lot of code for something that's very simple, right? And it was kind of okay in Java because we couldn't do any worse. Well, no, we couldn't do any better. Well, we couldn't do any better or worse, really. But in Kotlin, especially where we can't just mark a thing as static, we have to put it inside a companion object and it gets like expanded and so on. It just seemed to be so much worse in Kotlin. And so our aim really is to refactor this into something that's, feels like it's nice enough, and also to make it into a single expression function, because I think I'm on record as saying if the aim isn't to make everything single expression, I don't want to play the game. And two strings already a nice little single expression, and so in Kotlin we can oh, well done, thank you, that's the perfect thing, like you read my mind. So we can either have functions that have a block like that one and have a return statement that says what they return, and you need a return statement unless your return type is unit or void in Java. But in Kotlin, if we have a single expression at the top level, then we can convert it to, so if we were to put, for example, println before that, convert it back to a
like that.
So if you do println, then we can't. IntelliJ won't let us convert it because it's two expressions, two statements, whatever. But if we take out the println,
well, to be clear, that's an expression now. That's another, and we still cannot convert.
We still can't do it because it has to be a single expression at the top level. Now there is a trick we can use, in fact, to just let's practice here. So we can, in fact, we could make that all into a single expression with a run, which is cheating a bit. So we could say run if we took the return out. Then that, even though it's got two statements in it, is a single expression because Kotlin run just says take this block of code and return the result is the final that final bit in line 9. But that seems cheating. So we're not going to do that, but we are going to try and make things better. And it's kind of it's my experience and maybe yours that if we try and make things single expression, our code just tends to end up better. When we succeed. And the aim of this exercise is to see whether we can do that and to learn a bit about expressions and statements and that sort of thing.
Yeah.
So let's put run back. Let's put toString back together again, and ask ourselves the question: what is it in our parse method there that's stopping this being a single expression? And when I say ask ourselves, the question, I'm going to ask you the question.
Okay, put me on the spot, right?
Well, this is like pairing.
Well, there is a value, right? Used all over the place. Then we have @index, and then we have require. So that require is kind of in the way, I feel. If it wasn't require, we could have at least like inline @index. That's not nice. Or something like that.
Actually, so we can inline @index. If you inline @index.
Should I?
Yeah. Okay. And then run the tests.
Thank you. There is no TCR this time, right? I can safely run.
Yeah, I think TCR is a fad. It's a fun fad, but it's a fad. And it's worth asking ourselves why that refactoring is safe, right?
Should we do this as well? Sorry, like to jump.
Yeah, sure. I mean, we're about to toss this code anyway, so because it's not going anywhere, frankly. Yet another one of these things isn't going anywhere. But we can do this because value last index of @sign is it always returns the same result, right? If it ever returned a different result, or if it ever wrote to a file, or if it ever did anything that wasn't just a pure calculation, then we couldn't make this refactor safely. But because it is just a calculation, we can substitute our, if you just revert, I guess, to where we were, we can substitute that local variable, or in fact, I guess we can go the other way. We can say let's take value last index of @sign, and we can pull that out into a local variable, and maybe IntelliJ will do the right thing.
So you want me to do that?
Yeah.
And call it last index.
Yeah. Or @index, I think we had before, but doesn't really matter, does it? So these refactorings are often only safe because we're relying on code and doing things or not doing things. In this particular case, we're relying on code not doing things. The things we're relying on not doing are writing to a file or sending emails or returning a different answer every time. Anyway, so the version with everything sort of expanded, inlined @index, still it works, and it would be a way of getting rid of one of our three. We've got 3 lines there basically, and we need one. We've got 3 expressions, and we need one. We've got. I don't know whether we'd call require. I think we're going to call require a statement, right? So I think we're going to call. What is @index?
The units.
It returns. Yeah. I think we're going to call it a statement, but okay. So we tried inlining everything. That didn't. I mean, that made everything. I mean, it's good for computers, but it's not great for humans because we're relying on pattern matching to see that those are all the same concept if we inline. Let's what we really want to do now is we want to find a way of evaluating at index once and using it in a lot of places, right?
So
And
we're gonna use
assigning to local
then.
variable. Well, no, not yet. And we will try that
Okay.
later. That's step 2. And I you know, and I would also go for that. But in order to sort of sketch out how these like how code works, if you like, let's try pulling all the code from 12 to 19, but not including 12. Sorry.
Right. No. Okay.
Let's make a function out of that.
Right. What should I call it?
I'm going to call it. I say let's call it email address because it's creating an email address, and let's maybe swap those parameters around because it's the email address from that parameter. Yeah. So if we do this, then I mean, one way to look at index is that it's a one way to look at that assignment to at index is that it's a thing that can only happen at one place in the code. In fact, if we revert this, let's just have another little look at it. Right here, at index, we can't move that assignment to that variable anywhere else in this anywhere else here.
Yeah, right? Yeah, of course, because
because it's needed, right? And so that becomes a thing that we couldn't do lazily. Well, we kind of did it lazily when we expanded it, I guess. We inlined it. But assignment to variables is a bit of a problem because it means that we can't move our code around like we'd like to. And we don't think of it that way, but it is like that, right? So that assignment is a statement, not an expression. So if we go back forwards, we can sort of take that time order out by extracting the function, right?
You mean we have in the function now? And
yes. So in other words, because that function call, the language, the Java virtual machine, I suppose, is going to evaluate at index before it's required an email address.
Right. So
we've kind of what you're saying. Go ahead.
No, it's like I guess what you're saying, if I paraphrase it, is that when we do an assignment, that's a side effect which kind of creates a scope of visibility of this side effect for the rest of the function. So as soon as we do an assignment, like you can imagine this nested scope.
Yes, we have a scope of the time after that assignment, which is why what we did was we selected all the things after the assignment and we put them into another function.
Yeah.
Right.
So now this time is this time is explicit now in this function, basically.
Yes. Yes. So what we've done is we've made a scope in which at index exists. In which at index exists all the time. So previously the function had a scope where it. At the beginning of the function, it wasn't there, and at the end of the function, it was. After the assignment, it was. But by extracting this function, we've got a scope where it has to be there, and so we can inline then at index in from 12,
and convert this to expression.
And now we have a single expression function. Okay. And
should I leave the type or should I go into the new line? What do you prefer?
Well, I mean, personally, like I prefer the new line, but then I'm trying to format things to fit on paper in a book at the moment, so getting that way. And I put the type in if it's not completely obvious. And there are people who say put the type in for every public method. And I think
I'm one of those.
Yeah, that's not a bad rule. So we've managed to make our first our top level thing a single expression, but everything is a bit worse because email address doesn't um, email address value at. I mean, it's not a thing that seems to add any value to this code, right? But we're going to push on a bit. When we get, so we've now got 2 statements in email address. So it would be fine to have. I wouldn't mind having 2 single expression functions to solve this problem if they were both good ones. But let's see how we can make email address into a single expression function as well.
Okay.
I think. So we've got 2 expressions, and what a good trick at these sort of points where we maybe don't know which way to go is to inline a thing that's causing us problems. So what we want to do now is we want to inline require, and irritatingly we can't do that. I don't know why we can't do that, but if you try and inline require at this point,
okay, I'll research a U-track issue then. Well, I'm copying this code. What do you want me to do? Copy
yeah. So what we're going to do is if you just try it, I mean, you'll see that IntelliJ will tell you that you can't.
Yeah, I'll just try inline refactoring. Yes. It says. Okay, good.
It says you can't do that, even though you can see it. So what we're going to do is we're going to go and take the thing that we've got. I would go the other way. I would go down into require. So step into the source of require, copy that whole function.
Just like that.
No, that way. And let's put it into our code base here. That'll do it. So we don't need that. We don't need that. Yeah, and now we can inline it.
Right.
We were about to lose it all in, so yeah.
That's so much better than doing it manually. I was so wrong. I'm embarrassed.
Okay, so at this point, it's all a little bit weird. Because of the way that the inline is working, because we had a lambda block in there, we have double negatives in our at index, or have you got rid of those already? That's a bit weird.
That's better.
That's better, yeah. Then we're creating a lambda and evaluating it straight away on 16 to 18.
Right. So
basically, I don't know there's any good way of doing that other than just taking all of the punctuation away. Yeah, and then we can inline message.
Oh, of course.
And we can run the tests.
Done.
Okay, and now we're that throwing exception's a bit weird, right? But we'll leave it alone. It's all okay. What we're going to do is we're going to put an else in, because if we put an else in, it won't change the structure of this. But so that will still compile, still run, still pass tests.
I'm just thinking about formatting. I guess I'll add braces for sake of it.
And this looks, I mean, this is now 2 statements separated, chosen with an if statement, and it looks tantalizingly close to a single expression. So I think if you actually alt enter on return, no, not there. No, you don't even have to do that. Oddly, you can just alt enter on the first return.
Right.
Yeah. Okay, so we now have a single expression again. And so we now have 2 single expressions, and we can make this one, we can alt enter on return, convert to expression body, and that's nice. And personally, I find these things really a bit better if we make that a when, so we can alt enter on that and make it a when.
How do you format on the new line?
I tend to drop it down, because otherwise things change too much. We have got more braces than we need there, but apart from that, I mean, so we now have 2 single expression functions, and we could declare victory, except that email address value at index is just rubbish, really. I mean, it hasn't helped.
I do that for clarity. I would do that on real code base because it's
yeah, that's great. Yeah,
okay.
but I mean, it hasn't helped the fact that our code is now longer than it was before. It is 2 single expression functions, so I guess we score 2 points. But I can't put my hand on my heart and say it's better. I don't know about you.
Mm.
I think it's worse, right? Because email address is just it's a nonsense function that is only there. It's only there in order to score us points, really, isn't it?
Yes.
So I'm going to say that's worse, and we're going to throw it away and start again. I mean, we could try and go forwards from here, but let's toss this code and try and do it. Yeah.
Complete rollback.
Complete rollback to our initial state. Yeah, that's the one.
Oh wow. Okay. So I tapped all of that for nothing, right?
Well, I mean, I think
well, we learned, right?
We learned something. Well, I mean, I hope we learned something.
I did. Full refactoring of inline in library things.
Yeah, that's quite a nice stunt. Okay, so you rightly said when I pulled the function out that could we just use a let? Because let's job is to define a scope in which there is a variable. And so I want to back into this a bit. So yeah, I admire your. I'm gonna refactor very, very slowly into this just so we see where we're going. Right. What we're going to do is we're going to surround 13 to basically the entire body. Yeah, that stuff. Everything we extracted in a local function before, we're going to surround with a let. And I don't think that's I don't think that is a thing. Unfortunately, okay. You can put the braces around it as you did that. Yeah, but you can surround it with braces and then you can run. Put the let. Oh, okay. Yeah, run's almost the same. I mean, worth just running that as it says run, and I mean, I guess it's all the same. We've got this odd thing that we are returning. It's a statement in the middle of a.
Also, it's worth running test because the surround with is not refactoring; it's a transformation. So
let's put a let in there. And that surprised me a bit because I expected there had to be something on the left-hand side of a let, but it turns out you don't.
Well, whatever this is in this context.
Yeah, I don't. I if you put it's nothing. If you were to put it and ask it on the right-hand side of that.
Oh.
No, on the at the end of that line and ask what the type of it is. So on the end of 13, what is it?
It's companion.
Companion. Oh, so it is this. That's
so there is this.
Right. That's unexpected to me. So we can put a return statement there, right? So we can lift that return out of our out of 17 and into here. Yeah. And that will be the same thing.
Yeah.
And now what we want to do is we want to thread at index through. So we're going to copy. So we're going to say at index.let.
Oh, I thought it would be. Okay.
Well, it's good. Yeah.
Other way around.
Other way. I mean, yeah, you can't compile it until you get there, but.
Well, yeah, no, that's a much better step. It stays green, like is it compilable, right?
Well, so I would have actually taken at index. So I would have said, don't take the value of at index.
Oh, I see. Thank you. I misunderstood. So you mean that's the first step? It's all compiled.
So that's one step that compiles and runs. Now you can make at index the name of the of it effectively in there.
Right.
Yeah. That continues to compile and run, and that shadow. So that's not the same at index, but it's going to have the same value. Yeah. So now we can inline at index.
Nice, I like that.
And now we have and now we've got a single expression. And there are various things we could do to make this a little bit nicer. I mean, require is kind of weird because its job is to stop the next line of code running, right? Its job is to throw. I've played with putting last index of also require and then let, so that you can see that those are two sort of different things.
Can you explain that again?
Yeah, so the I mean, these are two separate steps in a way. One is just, it's a guard clause, right? 13. It's saying don't carry on if some precondition isn't met, right?
Yeah.
And we've got also, which we can use to use a value. So we could split this up into two different bits. So we could say if we say last index of dot also curlies.
Last index.
So after on line 12, just before the let.
Yeah.
Just before the let. So inside.
Yeah.
Inside line 12, as it were. Yeah. So dot also.
All right. Okay, I missed that.
Yeah. So we could sort of set this out this way, and we could move our require into there. So also is also as a way of sneaking in sort of side effects.
So we're doing this basically.
Yeah, we're going to put that into there. Yeah.
It's going to be at index.
Yeah.
And then we can paste this into there, remove from.
Yeah.
That's what
so also is a way that we can sort of sneak an expression in. And so that I mean, I don't think I like any more or less. But this is about sort of ways to get single expressions out of things, and that's quite a nice one. It sort of suggests that that the code inside the also is tangential in a way. It's like it's not actually what we're doing here, but it's another thing we have to worry about. I don't know. I think it's worse anyway. Whichever way you look at it, we're not scoring any points for making this nicer than it was to start with, I think.
Okay, should I go back then?
I think we're gonna toss it, and yeah, let's see.
Going back to the original state.
Yeah, back to the original.
I revert everything.
Yeah. Once again, I mean, we've learned something. What we could try and go for. Sometimes we think we can power through and get there from here, and sometimes we think it's not worth trying to power through. I've got a quick typist. It's all good, So what we're looking for now then. So basically we have, by concentrating on at index, we failed, I think. So we said that at index was our problem. And if we could only deal with that, we would have something nicer. We'd have a single expression. We found a way to make a single expression, but it didn't make a nicer code. What we're trying to do is make nicer code. And so if we're not going to focus on at index, the question is, what sort of clever thing can we do that isn't, what's trying to get out of here? And I know you haven't read the chapter, so I'm going to ask you the question, and you can either be really clever or I can be really clever.
I was really trying to understand this require, why it's doing equality on that bit. Not sure it makes sense to me.
We should talk. Well, yeah, we can talk about that.
It cannot be the last. So if we have at, it has to be after the first character with index 0, and it cannot be the last index. So that's incorrect. And it cannot be -1 because last index will return -1 if it's not present. So there are a few things there.
And it can't be 0 either, because and actually that's a really good time to focus on this, because that message maybe isn't giving us quite enough information. What that message should really be saying is email address must be 2 non-empty parts separated by at.
And it changes or not?
by all means, please do.
On empty. Just don't know if there will be a failing test after this.
No. I may be fastidious in my tests, but checking error messages is not normally that fastidious. Okay. So having said that, and I think that not is worth getting rid of as well while we're there. You can. We made that change at some point, didn't we? Yeah. I think that's a nicer way of looking at it. The at index has got to be greater than or equal to 1, and it's got to be less than, got to be off the end.
We can also replace it with a range potentially, so it should be in the range between 1 and value length -1 or something. Like, you know what I mean?
Yep. Yeah. I personally, yeah. I don't think it ranges as much as I maybe should do. Okay, so it now, but by sort of pulling on that thread, as it were, maybe we can say actually the idea of a string that's two non-empty strings surrounded by another thing would be a far nicer concept than any of the others we've got so far. So in other words, really, it's what we were focusing on before was that at index, but what we should be focusing on really is the parsing of the string. So what I propose we do is we take line 17, the expression line 17, and we extract that into a local variable, right? And that's basically our left part. I mean, it is our local part, but if we're thinking more generally, it's our left part. And that's our right part.
And we can do splits maybe.
So split does a slightly different job. A, it uses regex, and B, it is deliberately what it is. There are other ways to express it, but
okay.
Okay. So what I propose we do, let's, as we did before, we're going to take everything before the return statement, and make a single function out of it.
So this becomes a function.
Yes.
Called,
well, let's call it split because that's what it's doing. And it's quite interesting that IntelliJ is smart enough to see that there were two things that were required, two results required from this function. So it's actually made it return pair of string and string, which is quite sweet.
Yeah, that's really nice. Yeah.
And now we can just basically pull our let stunt here, right?
How do we do this step by step? We're doing this, then we.
So I would go back one from there. So I would put the let in around the whole return. So I would, surround that with the braces. Change that to let. Then say return let something. Yeah. Just run that at this point. Just check.
Yeah.
Okay, and now you can take. Now it's a little bit weird because of that, because of the destructuring. So it's probably easiest just to paste that in there.
In this, it still compiles, and then we
still compiles.
Paste that into key and shadow variables essentially.
Yeah.
And we don't need that, and that's it. Nice.
Okay, now we have a single expression. Now we can just lay that out a bit. And now that feels like we've added value to me. Right? We said we split a thing, we split it into a left part and a right part, and we are creating an email address from it. So all the other solutions up to this point, I felt we've made that first expression worse. And this one, I feel actually we've raised the level of abstraction now. Which only really leaves 16, that whole split thing. And obviously we want the points for we want the points for making that into a single expression. So how are we going to do that?
Not sure. More lets like what?
Yeah. I have no problem with. I have no problem with lets at this point. So we should be able to, at this point, we should be able to inline it left part and right part, right? I just sort of starting the simple way.
That's pointless for a second.
Or 2 is fine. Yeah. So actually, as a return, I find 2 a little bit.
Oh, I see.
I think it offers a refactor. It offers a refactor. I think if you go back 1, I think if you alt enter on the pair, in convert to 2. There you are.
Yeah, that was fine, but I find this easier to understand.
Yeah. In the book, I had the 2 form, and I've got
to. Let's do 3.
I lost the stream. Lost the stream a bit. Okay. Okay, and now let's make this a let, right? Because it will be okay here. So we can go through its steps again, which is put a let all the way around those.
And we do at index.
Yeah, you can. Yeah, I don't think it matters when you pull the return out, but you need to pull the return out as well.
Cool. Yeah, pull the return out. I'll run tests. And we do at index. Then we shadow it.
Yeah.
Then we inline it. Nice.
Splendid. And then I think let's make this into a single expression. Well, it is a single expression. Let's alt enter on the return. And now this thing, I think I would pull out of this companion object because it doesn't really have anything to do with this class now. It's used to implement a bit of this class, but so let's pull that to the top level, just in here for now. And now a good name ended up with split around. Because split already is already, well, in fact, so step back 1. Let's make this into a extension function, right? Oh, where's it gone? I think where we were was fine. Extension function and then pull it out, whichever way. That's the way.
So this, right? String split.
Yes. Yeah.
And then pull out of companion.
Pull it out of the companion.
To here.
Yeah. And now our original method reads value split let, which is much nicer. And the only problem is there is already a string split that you pointed out before that we could have used to implement this. So I was trying to find a name that suggested the non-empty parts and also made you not know what it would do so that you'd have to actually look it up. So that, trying to find a name where you don't assume that you know what it does, but once you've read it, you remember what it does. Well, split. You don't know what it does. You don't know there's anything special about it, and you don't know it's different than the normal string split one.
No, this is a bit confusing, I would say.
Yeah. So I came up with split around because
split around.
Yeah, because split around kind of suggests the non-emptiness of the bits either side.
Do we make it a parameter?
Absolutely that. Yes. Sorry, that probably should have done that a while ago, shouldn't we? Perfect.
Yeah.
I think that I would call that C divider, but
that's a better name.
And then obviously line 21 also says email address, and it's this is no longer an email address, so I would just say string. String would be fine, wouldn't it?
Yeah, sounds good.
and I think that's all right. I mean, so the problem now we have is that moral question of this feels like a nice top level general utility function, but if it is, then we have to write unit tests for it. So I think in most situations I would leave that here as a thing that I remember, might remember that I have lying around and I could pull out of here if I wanted to use it in other situations, but probably leave it here. But I think we're done. And that was how long? That was splendid. Half an hour. So what have we learned? What have you learned, Dimitri?
Well, I definitely learned a couple tricks around safe let refactorings and that they're not present in the surround with. I wish it was part of this thing. That's maybe
it is a bit weird.
Request. That was nice. And the technique for inlining required by copying it, and another feature request to inline library functions.
Yeah, I mean, you can see why it doesn't. Why you can see why that is hard to do, because a general function may have loads and loads of scope around it that's important to it, but lots of functions don't. I mean, we aim for functions that don't, right? We aim for functions that are standing alone as general as we can possibly make them. So yeah, it is a bit of a shame that.
Yeah, and I guess overall the main thing was about not always focusing on tiny bits and maybe thinking about bigger picture of what you're doing, I suppose. Is that a thing?
I mean, that having been through this exercise, myself, and trying to write about it, I think that that was one of the takeaways for me. I mean, I personally so often tidy my way into better code. So you just say, okay, well, look at this now. Why is that like that? Oh, well, we could make this a tiny bit better, and we can make this tiny bit better, and make this tiny bit better, and hope to get to some place that's good enough. But what we found here, in fact, was that those tidyings weren't enough. They just actually made things a bit worse. And so sometimes, I think sometimes tidying's fine, and sometimes we have to say, okay, we'll step outside and we'll step outside the problem, and we will look at what this is trying to say to us. And I was quite pleased with split around as a concept. But yes, this idea that striving for what I found is that if I can make as much as possible of my code base single expressions, it tends to be things that are about the right sort of size for me to reason with, and it tends to be things that are functional, which is to say they're just, because they're expression based, then they're just they're just calculations rather than generally having side effects. And also, yes, this striving for what other more general concept is trying to get out. When we fail to get there by just mechanically tidying, can we find something nicer that would be generally applicable? Something almost algebraic. Is that too posh? I don't know. Maybe cut this bit out. But this was fun. This was a fun one for me, and it's been a fun chapter to write. So the point of this really is to plug the book, which is refactoring. No, it's not refactoring. It's Java to Kotlin, a refactoring guide book, which O'Reilly have on I don't know what, early access, rough cut, I think they call it, or something like that. I'll put a link probably in the YouTube video. We have, I think, 3 chapters out and many more sitting in the pipeline. This one, I think, is almost ready to go.
When is it going to be finished? By Kotlin 1.5?
Don't make us race. I suppose, we're probably hoping that we can get it out before Kotlin changes enough that we have to, have a new edition. I think certainly it's not going to be this year. It'll be sometime next year. I'm hoping by the summer. I think we'll have lots of content out way before then. But obviously, actually publishing a book, it turns out, is quite a long lead time thing.
Oh, sounds good.
Did I mention Nat? Yes, and I'm writing the book with Nat Price, who we all know is a genius. So it's going to be an excellent book.
Sounds amazing.
Dimitri, I really appreciate your help.
You're always welcome.
Excellent typing as usual. You are my favorite typist.
Thank you. Duncan's favorite.
I got to wrap this up. See you later.
See you.